In this video, we'll look at how to divide polynomials by using synthetic division. So last video, we looked at long division, kind of a riff off of an old algorithm that we know from elementary school. In this one, we'll introduce a new kind of division tool called synthetic division. So if we want to divide p of x equals x cubed minus 7x plus 6 by x minus 1, we could do that by long division, or we could try this slightly more efficient tool called synthetic division. And just as in long division, the setup, we have something divided into something else. With synthetic division, we'll set it up like this. We'll have kind of the flip of that, and we'll take something here, divide it into something here. So let's talk about that. So, something to know, we can only use synthetic division when we're dividing a polynomial of degree greater than 1 by a polynomial of degree 1. This is important to note because otherwise it won't work. Next, we can kind of solve x minus 1 equal to 0. So we have x equals 1. We take this and set it up here with the bar like that, like this. So we take the coefficient in front of each term in the polynomial. So we have 1 in front of x cubed, but then here's a trick. We don't have an x squared, but we have an implicit 0 in front of the x squared. We have negative 7 in front of the x, and then we have 6. So here's the process. The first thing we do is we take the first coefficient and drop it down. So we have 1 here. We take our divisor and multiply it by the first number in the bottom row. So we have 1 times 1, and then we place that in the middle row. Then we do 0 plus 1, which leaves us with 1. Again, we take our divisor, 1 times 1, and put it in our second row beneath negative 7. We add negative 7 and 1, so we have negative 6. Then we do 1 times negative 6, the divisor times the next coefficient in the bottom row, so we have negative 6. And then we add 6 to negative 6, leaving us with 0. Now implicitly here we have an x squared plus 1x plus negative 6. So we start with the highest power. If we have 3 terms, we would start with an x squared because a polynomial of degree 2 has 3 terms in it. And then we just go down. Of course, if we have a 0, then we don't really count that term. So we could just as easily have had a 0 here, and our result would be x squared plus negative 6, or x squared minus 6, but we ended up with a 1. So altogether, we can say that we did x cubed minus 7x plus 6 over x minus 1 equals x squared plus x minus 6, and this last coefficient in the bottom row is our remainder. So we could write that as like 0 over x minus 1, equivalently just x squared plus x minus 6. It's important to note that in some cases, when you end up with a 0, that just means that whatever we're dividing by, we're dividing x minus 1 into our polynomial p. It just divides evenly into it. We'll get into that a little bit more later on, but just something that you might happen upon. Okay, so now let's divide 2x cubed minus 7x squared plus 5 by x minus 3. We'll use both synthetic and long division, so you can just compare kind of the visual aspect of the two different types of division. So first, let's start with long division. So we'll set it up. X minus 3 goes into 2x cubed minus 7x squared. Now this is a bit where I'll typically write a placeholder. Since we don't have just an x in our original polynomial, we can write plus 0x plus 5. It's good to have those placeholders so you don't lose track of your long division. Okay, so now the first question is this. What do we need to multiply x minus 3 by to get something close to 2x cubed? We should start with 2x squared. So we'll multiply 2x squared. So we'll multiply 2x squared by x minus 3. So we have 2x cubed and then minus 6x squared. And we'll subtract that. So we'll have 0 and then negative 7x squared minus negative 6x squared, which will leave us with a negative x squared. Then we bring down the 0x. So what do we need to multiply x minus 3 by to get negative x squared? We multiply by negative x. So then we have negative x times x minus 3, which gives us a negative x squared plus 3x. We subtract. So we have a 0 and then a 0x minus 3x, which gives us a negative 3x plus 5. So we bring down the next term. So what do we need to multiply x by to get negative 3x? So we'll multiply by negative 3. So we have negative 3x plus 9, which then, following our same process, leaves us with negative 4. So if we divide 2x cubed minus 7x squared plus 5 by x minus 3, we get 2x squared minus x minus 3 plus negative 4 over x minus 3. Let's see if we get the same thing by using synthetic division. So remember, we can only use synthetic division if we have a polynomial of degree 1, i.e. a linear term. And we set it up like this. We solve for x minus 3 equal to 0, so we have 3 into, and now here we'll also need to use a placeholder like we did before. So we will need a 2, a negative 7, a 0, and a 5. So now, first thing we do is we pull that first coefficient down. We take that 2 down. So then we multiply 3 times 2 and put that in the middle row below the next coefficient from the polynomial. Then we add negative 7 and 6 to get negative 1. 3 times negative 1 is negative 3. 0 plus negative 3 is negative 3. 3 times negative 3 is negative 9. 5 plus negative 9 is negative 4. And then we could just kind of fill in the gaps here. So we have a 2x squared minus 1x minus 3, and then that last coefficient is our remainder. So it does check out. This is the same. So we can see that both synthetic and long division do get you the same result. Just have to remember that long division, we could actually divide larger polynomials into larger polynomials. We could take a polynomial of degree 3 and divide that into a polynomial of degree 6 or 7. When we're doing synthetic division, we can only divide some polynomial by another polynomial of degree 1.